I will speak today just 1 minute about who we are and what we do in Microrelleus. Then 1 minute more about the technology that we use, and then we are going to focus directly on this topic through some examples that we have, some of them in the market, some of them are at the end. So, we are a services provider for the industry. What we do is laser microstructuring, surface texturing, and industrial engraving services. So, we engrave the production tool inserts, the molds that our customers use to produce. We are in the market since 1983 using different technologies. We are placed in Barcelona, and in 2016 we were world pioneers offering femtosecond laser services in 5-axis, and in 2022 pioneers for big and heavy tools, because before there was no technology available. So what's this about? What's this femtosecond laser technology that we use to engrave molds? Comparing with a nanosecond laser, the femtosecond laser is an ultra-short pulse duration laser. So we are able to do a cold ablation, some people say. So we can engrave parts or production molds with the characteristics that we can see here. Clean engraving with sharp edges, absolutely work-free, high-quality surface finishing, excellent tolerances, and we can engrave over any material. And we can do it, again, on absolutely standard steel tools over any 3D shape, up to more than 1,000 kilos. So we have smaller engraving details for new possibilities in engraving, for new possibilities in lighting. We can engrave freeform microstructures and microtextures, again, in absolutely standard tools. Beginning with this example, that's the Cupra Tabascan concept, released some years ago. In this case, we engraved thousands of microprisms in the tail lamp of this concept car. So the LED is coming from the top, and thanks to the thousands of microprisms engraved, in this case directly in the PMMA part, we can obtain the homogeneity from behind. So there's a possibility to work on 3 dimensions because all the electronics is out of the tail lamp. So thanks to the engraving, we can work in 3D shape. In this other example, that's a production car, Range Rover Sport 2023. We engraved the prototypes, but we engraved also the production tool inserts, the molds, to achieve this nice homogeneity on the tail lamp of the car. So here we can see some images of the tool microstructuring, the micro-optics engraved directly in the mold, some injected parts, and the final product, which is in the market, to achieve this homogeneity, because the light is coming from the top and from the side. In this other example of our customer Odelo, this is a nice example because we can see some logos, some images from one side, but if we turn the part, or if we look from another perspective, what we are going to see is an homogeneous appearance. So the LED is out of the part, the light is coming from the side, and we can see an image or homogeneous light. We have this example in our booth here in the room, so if someone wants to take a look, we'll be happy to show. And in the images, in the microscope images, we can see the detail of what we are engraving in the steel mold. This is another example of our customer OP Mobility, Plasticoming before, for their product Illuvision. In this case, we engraved again thousands and thousands of micro-optics in the mold. We can see some images here. For a final product, for this Illuvision new concept of tail lenses that has ultra homogeneous appearance, super 3 frameless design, simple concept, fully 3D dimensional shapes with a semi-transparent appearance. So everything here is possible just by injecting transparent plastic in a mold that has been microstructure using this technology. This other example from Pretel is quite similar than the previous one. The LED is coming from the side, and we have this effect on the semi-transparent parts. We have developed with this femtosecond laser our microscat technology. So microscat means microtexturing and microstructuring for light scattering control. We realized that in the industry there was the need of the diffusion of the light to control the diffusion of the light, and there were some other possibilities, like engraving the tool with standard EDI textures, where the homogeneity is not really good, some films using diffusive materials, and some other options. But all of them has had a lot of disadvantages, and we tried to put together the advantages of the technologies in just one step, and that's why we developed this microscat technology. So what's this about? We are engraving the mold with this kind of patterns. We can see the 3D representation on the left. Next to it, confocal microscope analysis of what we are really engraving in the mold. And next to it, in the middle, we can see some parts that are injected using transparent material, transparent clear, and transparent red. And as you can see, we can't see the hot spots of the LED that are behind them. The surface is homogeneous, and this is possible just because of the engraving of the mold. We're using the femtosecond laser to engrave the mold. This is important to be sure we are really engraving the same because of the avoidance of burr. So we are really controlling what we are micro-engraving. The diffusion is high-quality diffusion with great luminance, good anisotropy levels, and the randomness of the texture of what we are engraving is controlled by an algorithm. So how it works? It's very easy. We have different preferences for circular diffusion, even for elliptical diffusion. We have the files to do the simulation in softwares like LucidShape, Light Tools, Speos. So customer is able to simulate the behavior by using our references, then deciding the area where they want the controlled diffusion. And what we are going to do in Microrelleus is just engraving the tool, engraving the production mold just on the areas that they want with the correct reference. And mold is going to injection, no more steps. Environmental benefits, material reduction, easy to recycle, energy production, design benefits, beautiful finishing, ultra thick pieces possibility because the diffusion is not dependent on the thickness of the part. We are achieving the thickness just because of the texture that we are engraving. Free-form design area, and cost-effective benefits, material reduction, weight reduction, processes simplification, as we saw before. In this case of the Cupra Formentor and Cupra Leon, released just a few months ago, they are nice examples because we engraved the microstructures and we engraved also microscat, so it's a good combination project. As a first step, that's the concept that we saw before in the Cupra Tabascan, released years ago, but was the beginning of what we can find nowadays in the market. This microprisms concept for the light distribution, engraving of the PMMA prototype parts, and then engraving the microprisms in the production tool inserts. After engraving the prisms, we are engraving as well the microscat technology in the sides of the blades and also over the prisms to increase the homogeneity of the prisms. The final product that we can see nowadays in the market is the Cupra Formentor and Cupra Leon 2024. Some other examples released this year in the market that are using this technology are the Renault Rafale, where we engraved all the micro-optics in the production mode of the tail lamp. The Lancia Ypsilon, where we engraved our microscat technology to increase the homogeneity and avoid the hot spots of the LEDs that were visible when applying the textures. and the Fiat Topolino, where we engraved all the microstructures, all the micropillows in the production lines. But we are not working just in automotive lighting, we are working in general lighting as well. Here we can see an example of emergency lighting. So the idea here was to use micro-optics on the mold for the reduction of elements, complexity, size, material, and cost. So here we can see an image of the tool insert with the engraving, the plastic injected part, and the customer asked us to engrave 3 different patterns for different behavior for the light on each case. So finally, the solution was functional, cost-effective, environmental friendly, and with design benefits. Some other possibilities, the creation of hologram for different images, depending on how the light is going to the part, backlight, coating removal, or even possibility to have anti-glare parts just by the engraving of the mold. As you can see here, the border of the part is shining a lot, but the central black area is not shining. Just by injecting plastic in texturized tool with our references for anti-glare. So that's everything from my side. Thank you so much for your attention. And if you have any doubt, I will be happy to try to answer it.
Thank you.